Okay, class, we are moving on to the final kind of shift, which is a phase shift, which is a horizontal shift. And if you remember from Algebra 2, horizontal shifts are always moving in the opposite direction as the sign would indicate it. So here, I want you to be aware that the original equation has a minus c. Okay, so it's a minus. So in this, when it has sine of x plus pi over 2, that's really when we have a shift of sine of x minus a negative pi over 2. Okay, so in the position, right, so it's x minus your c value, x minus c. So when you see a plus, I want you to remember, oh, that's the opposite direction, so this is going to be a shift left. So like with vertical shift, the d value, if it was plus 2, it would be up 2. If it was minus 2, it would be down 2. With the horizontal shift, horizontal always is in the opposite direction. And so since it's x plus pi over 2, it's going to shift left pi over 2. Okay, so it's going to go left pi over 2. Okay, because my c value is negative. Okay, so I'm going to illustrate. So the original function is a positive sine function. You can see the key points, 1, 2, 3, 4, 5. So when you shift left pi over 2, all of your key points, so I'm going to circle my start. Now let's look at the green. The start is now over here. It shifted left pi over 2. And my maximum went left pi over 2. Or across the x-axis went left pi over 2. The minimum went left pi over 2, and then the end point went left pi over 2. So my one period of sine was shift left pi over 2. So the general rule for phase shift is C over B. So you're going to have to add that to the list you need to know. So you need to know period is 2 pi over B. The x-axis scale is going to be period over 4. The phase shift is C over B. So looking at the sine function, which is blue, sine of x minus pi over 2, that's going to be a shift right pi over 2. So it's going to be right pi, so not pi over 2, right pi, because c over b is pi. So my blue sine function started here, and then went up, down, 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 and ended. And that's one period of my pi function, the sine function. And when you shift pi units, remember your x scale, when the period is 2 pi, your x scale is pi over 2. So it got shifted. Originally my sine started here, but when you shift pi, it's going to start here. And you see this is where it starts going up, and then it's ending. So the start and end shifted over pi units, and you can see each value, like the max got shifted over, the min got shifted over, and so on. So the C over B is going to tell us the phase shift, or where we're going to take our start and shift it over. One thing that we are going to have to note is we are always going to need a common denominator between our x-axis and our phase shift. And that will help us figure out how we need to line things up. Okay, and we'll see that illustrated through examples. So in the first example, we want to know the shape. Well, it's a sine function. I know a sine function starts on the midline, it goes to its max, midline, min, and then back to the midline. So this is the general shape of the sine function. The period is 2 pi over b. My b is 1, so the period is going to be 2 pi. My x-axis is always going to be period over 4. So in this case, it's 2 pi over 4, or pi over 2. My vertical shift, this is going to be my d value. My d is minus 1, so it's going to shift down 1. So that's where I'm going to draw my midline, my mid or my center line. So my midline is going to be at the equation y equals negative 1. So I'm going to write the equation of my midline and draw it in here. And this is going to be my midline, and I'm just going to revolve it around that. My a value is 2, so my amplitude is 2. So I know that it's going to go up and down 2 from my midline. So instead of drawing in the base function going around the x-axis, I'm just going to draw it revolving around the midline. Okay, so then we're going to find the phase shift. The phase shift, which I'm going to abbreviate PS for phase shift, and the formula on the previous slide was C over B, so my phase shift is C over B. Remember that the equation was that it was y equals A sine B of x minus C plus D. So if I rewrite it as bx minus C, it's 1x minus negative pi over 2. Okay, so I know that my b value is 1 and my c value is negative pi over 2, which tells me it's going to start at negative pi over 2. My phase shift went left pi over 2. Okay, so it's c minus pi over 2 over b, which is 1, which is why it starts over at minus pi over 2. So the phase shift tells us is the horizontal shift, or the phase shift, where it's going to start. Okay, and we always need a common denominator between the x-axis and the phase shift, which we have. So that's good. And so if we start over at minus pi over 2, we're going to do one period, and then we're going to have the end point. So my end is always going to be the phase shift plus the period is always going to be the end value. And this is just a self-check that we're going to use to make sure that we graphed it correctly. So the phase shift is minus pi over 2. The period was 2 pi. And 2 pi can be written as 4 pi over 2, so it has a common denominator, and 4 minus 1 is 3 pi over 2. So it's going to start at minus pi over 2 and end at positive 3 pi over 2. So I'm going to start on the midline, since sine starts on the midline, and it started at minus pi over 2. So I have minus pi over 2, and it's going to start on the midline. And then looking at the shape, it goes to its maximum. When the amplitude is 2, my x-axis is pi over 2. So pi over 2 away, it's going to reach its maximum. And then pi over 2 away, it reaches the midline. Pi over 2 away, it reaches its minimum. And pi over 2 away, it reaches the midline. Right? So it goes around the midline. It started at pi over 2, and if I count my scale, my x-axis, my points are all pi over 2 away, so 1 pi over 2, 2 pi over 2, 3 pi over 2. So I have my 5 points that make up one period of the function. So I can connect the dots with a smooth curve and put appropriate arrows on both ends. It started at minus pi over 2 and it ended at positive 3 pi over 2. This one period has a distance of 2 pi, which is what we said it was. Okay, my vertical shift was down 1. That was my D value. My amplitude was 2, and I went up 2 and down 2 to minus 3. So I have my key points are all marked, and all of my dots have values marked on the axes. Okay, let's go on to the next problem. So this next problem, there is no vertical shift. We do have a C value, we have a B value, and we have an A value. It's a cosine function. It's a positive cosine function, so it looks like a U with the midline going through the middle of it. And the minimum. The period is 2 pi over 4, which is my B, or pi over 2. My x-axis scale is period over 4, so pi over 2 over 4, which is pi over 8. My vertical shift, remember there is no D, so there is none for vertical shift. The phase shift is going to be C over B. Since it's a negative pi, my C is pi, so it's going to shift right, and my B is 4. So my phase shift, where it's going to start, is pi over 4. And remember, we always need a common denominator. So So we're going to need an LCD, so we always need an LCD, the least common denominator between those two, and I'm just going to write both fractions the same. The reason we need a common denominator is because we're going to start at pi over 4, but our x-axis needs to be set up in pi over 8. So each box needs to be pi over 8, but the phase shift needs to be pi over 4, which in eighths is 2 pi over 8. So we need to start 2 boxes over because our x-axis is going to have to be in pi over 8s. Okay, but we're going to start at 2 pi over 8, which is going to be over here. That's 2 pi over 8, because each box needs to be pi over 8. The end is going to be the phase shift plus the period, and the phase shift was pi over 4 plus the period, which was pi over 2. 1/2 plus 1/4 is 3/4 pi. So it should end there. In terms of eighths, 3 pi over 4 is 6 pi over 8. So we want to make sure we end at 6 pi over 8. So if we count 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, or 3 pi over 4, this is where it should end. So the distance between the tick marks is pi over 4. We're starting at 2 pi over 8. Okay, so we're starting at 2 pi over 8. Remember, it's a cosine function, so we have to go to the maximum, which is 3. And then we go to the midline. And then we go to the minimum, which is -3. And then the midline, and then the maximum. So we reach the maximum. I'm going to connect the dots with a smooth curve. Put arrows on both ends. And I'm going to complete filling out my x-axis for my key points. I have 2 pi over 8, 3 pi over 8, 4 pi over 8, which is pi over 2, 5 pi over 8, and 6 pi over 8, or 3 pi over 4. So that is one period of cosine from the start to the end. We wanted to graph one period. Okay, so the tricky thing is when b isn't 1, you have to remember that the phase shift is always c over b, but by doing this, you get a number that often may not be the same as the x-axis scale. So we're always going to find a common denominator between the phase shift and the x-axis. The x-axis tells us how we need to split it up, right? Each box is going to be in pi over 8. And the distance between our key points is going to be pi over 8. And the phase shift tells us where to start. The reason we needed to find it in eighths, because the x-axis scale told us the distance between our dots for our graph, our key points, is going to be in pi over 8. So if the distance between our key points is pi over 8, and the phase shift is pi over 4, I need to know that I start 2 boxes over. So here is where it's important to really get the common denominator and understand the x-axis and phase shift. And that's what you want to be focusing on today, is figuring out how to set up your scale appropriately, because that's the new concept, the x-axis, phase shift, LCD. Okay, well that is all on phase shift. I hope you have a good night.